Remember, this is the problem that we tackled at last night. My question is, how far did we get? I just need to confirm that in solving this.
I remember that we have done Roman figure. There is Roman figure 2. We didn't do Roman figure 1 and Roman figure 3. Yeah.
We dealt with Roman figure 1 and Roman figure 3. Now, and then, problem solver. I said, oh, yes, hang on, don't worry. I'm here. Yeah, even this page confirms. Remember, we solved this system, eh? Yes, no? We solved this system in our last matrix that we had these entries. In the first row, the matrix had the following entries in the first row: 1, -2,
1,
2, 4. Okay?
It's what? Come again, say.
Let me say, this is the second last step. After this matrix, then I'll mention the last step, the last matrix. The matrix that we had had the following entries in the first row: 1, -2,
yes.
3, and 4.
Okay.
In the second row, we had 0, 1, A-6, and -3. In the last row, we had 0, 0, A-2A, and B-6. And then we went further, we said, this matrix.
Sorry, sir, please can you repeat? Sorry, sir.
Okay,
please,
no
can you repeat row number 3?
Row number 3. The entries for row number 3, I said, are 0, 0, 8, -2A.
Okay.
Or
8
-2A or -2A plus 8.
Okay, sir.
Then from this matrix, then the last matrix then was this one. And how did this, what is the difference between the matrix that I just mentioned and this matrix? The only difference is that in the third row, we just divided that third row by 8 minus 2A. And then the entries for the third row then became 0, 0, 1, B minus 6, all over 8 minus 2A. Is it clear?
Yes, sir.
Okay. Then I said, please remember the conditions, taking into account the conditions for number 1 and number 2. So I requested you to take it further so that you or we can then be able to talk about Roman figure number 2 when the system will have a unique solution. Remember? Forgot?
I forgot.
Forgot. Okay. Now, this is what we said. See? Oh, okay. Yeah. just having many page. This is, yeah, it's overlapping on a number of pages from my side. Remember for Roman figure number 1, let me come here. For Roman figure number 1, we said if A, sorry, we say, because the question is saying for which rationals A and B does the following system have no solution? Now, when we look at the last matrix, in the last row, the entries are 0, 0, 8 minus 2A and B minus 6. So, this matrix will have no solution if A is equals to 4 and B is not equals to 6. This is what we said. And then we're still saying it now. Do we agree?
Yes, agrees.
If A equals to 4 and B is not equals to 6, this system will have no solution. And then, for Roman figure number 3, for the system to have infinitely many solutions, we then said the system will have infinitely many solutions when B is equals to 6 and when A equals to 4. Do we agree?
Yes, we agree, sir.
Then, now, here is my advice. Since we know that if A equals to 4, and when B is not equals to 6, this system will have no solution. So now, the easiest way of handling Roman figure number 2, we know that if A is 4 and B, if A is 4 and B is 6, this system will have no solution. So now you can choose any values, preferably smaller values to work with, because ideally what we are looking for in Roman figure number 2, what should I call it? Or please allow me to explain it in this way. To say, remember, do you see this? This is the right-hand side, this is the left-hand side. Do we agree?
Yes.
Which one, sir?
This is the right-hand side of the matrix because of this equal signs. And these, before the equal signs, are forming a matrix on the left. This is but it's the same matrix. This is a 1 by 3, this is a 3 by 3. But this is the same matrix. Okay, now I'm here. This is coming from here. Do we agree? Yes, no?
Yes. We agree.
Now, if we agree, then this is how my story goes. My story then is saying, focus on this matrix on the left-hand side. Okay. But from that matrix, that final matrix that we are having, okay, this is the beginning. I'm referring to the last matrix, the one that we have after solving this matrix. Do you get me? The one that I just shared with you.
Yes.
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 So now, what do? Choose any, preferably small numbers, so that this thing can be easier for you to handle. Okay, let's say in my case, I know that if A is 4, this will have no system. If B is not 6, this system will have no solution. So then I chose A to be 2 and B to be 3. Still with me? I chose
Yes.
A to be 2, B to be 3. Then I solved. Okay, before I say I solved, I chose A to be 2, B to be 3, and retained the constants as they were in the matrix. Remember, if I choose A to be 2, whenever I see A in that final matrix, wow, the final matrix of 1, minus 2, 3, and 4, the matrix of 0, 1, A minus 6 minus 3, 0, 0, 1, B minus 6, all over 8 minus 2A. In this matrix, what I'm saying now, I'm choosing A to be 2 and B to be 3. When I do that, then the first row will remain to be 1, minus 2, 3, and 4. And then the second row will be 0, 1. Then we've got A minus 6. Then this will be 2 minus 6. This will be 2 minus 6. This becomes minus 4. And then there is a minus 3 on the other side. Then in the third row, we've got 0, 0, 1. Then we've got B minus 6. In the place of B, I put 3. Then in the numerator, I have minus 3. In the denominator now, I'll have 8 minus 2 times 2. 8 minus 4. This will just be minus 3 over 4. Are we together? The whole idea is to have an identity matrix on this side, on the left hand side. Okay.
Okay.
That is why I'm doing what I'm doing. That's why I'm saying choose the smallest numbers, not big numbers. Then from there, after choosing A to be 2 and then B to be 3, after substituting in there, now my matrix is now having the following entries, the one that I'm going to solve. 1, minus 2, 3, 4 in the first row. In the second row, 0, 1, minus 4, minus 3. In the third row, 0, 0, 1, minus 3 over 4. Are we together?
Yes, sir.
Then from there, the next thing that I need to do is to have 0 where there is minus 4 in the second row. Okay? So I multiply the third row by positive 4 and added it to row 2. Then, where did I go to that one now? Over here. Then, the new row 2 then becomes 0, 1, 0, minus 6. Then, I then said, where there is 3 in the first row, we need to have a 0. So that means I'll have to multiply the third row by minus 3 and add it to row 1. When I did that, then I ended up having row 1 as 1, the entries for row 1 as 1, minus 2, 0, and 25 over 4. Then from there, in the first row, I still have negative 2. Where there is negative 2 should be a 0. Then multiplying the second row by positive 2, adding it to row 1, then I ended up having 1, 0, 0, and 23 over 4. Meaning, In the first row, the entries are 1, 0, 0, 23 over 4. In the second row, the entries are 0, 1, 0, minus 6. In the third row, the entries are 0, 0, 1, minus 3 over 4. Yep.
Yes.
What is of importance to note here is that from where we are coming from, we are coming from this matrix. We substituted the values for this A and B. Now, these constants in row 1 and row B, you can choose them to be any letters. So I chose 23 over 4 to be U, and then minus 6 to be V. Remember, from that last matrix, we've already noticed that, what are the unknowns? Z is equals to B minus 6 over 8 minus 2A. So there is nothing that we can do with that one. Are we clear?
Yes.
Therefore,
yes.
Therefore, from there, then we conclude by saying, for this system to have a unique solution, X must be equals to U, Y must be equals to V, and then Z must be equals to B minus 6 over 8 minus 2A. That's it. Number 2 says, the augmented matrix of a linear system has been transformed by row operations into the form below. Determine if the system is consistent. The augmented matrix of a linear system has been transformed by row operations into the form below. Please determine if the system is consistent. Do you understand what I'm requesting you to do here? 1 minute or 2 minutes? Or 3?
3 minutes.
Yes, we're done, sir.
Okay. Number 2. What are we saying? Problem solver, what are you saying?
I think this one is consistent, sir.
Is consistent. We agree, yeah? Meaning it has got a solution. This matrix has got a solution. Thank you. I agree. Now, please, let's now look at number 3. Number 3. Number 3 is saying, is 3, 4, minus 2 a solution of the following system? 5x1 minus x2 plus 2x3 equals to 7. Minus 2x1 plus 6x2 plus 9x3 equals to 0. Minus 7x1 plus 5x2 minus 3x3 equals to minus 7. Is 3, 4, minus 2 a solution of this system? How many minutes? 1, 2, 3. Hello?
4. Done, sir.
Thank you. What are we saying?
3, 4, negative 2 is not a solution of this matrix.
Is not a solution. Problem solver, what are you saying?
Yes, I'm also saying it is not a solution for this system.
Okay. There is an agreement. So, I also agree with what you said. Then that takes us to this section, where we'll be talking about matrices and matrix operations. This definition is just saying A matrix is a rectangular array of numbers. The numbers in the array are called the entries in the matrix. This is what we have been doing. But just for formality, let me just say that matrix is a rectangular array of numbers. The numbers in the array are called the entries in the matrix. Okay. Now, this matrix, when we talk about the size of a matrix, we first mention the rows, then followed by columns. So, the first matrix is a 3 by 2. It has got 3 rows and 2 columns. That is why we are saying it's a 3 by 2 matrix. This one is a 1 by 1, 2, 3, 4. It's a 1 by 4 matrix. 1 row, 4 columns. Coming to this one is a matrix which has got 3 rows and 3 columns. It's a 3 by 3 matrix. This one is a 2 by 2 rows by 1 column. Finally, this matrix has got 1 row and 1 column. Okay, let me just say it. In this matrix A, this A sub 1, 1 is just referring to row 1, column 1. Entry in row 1 and column 1, that entry is this 2. Here is referring to an entry in the first row, column 2. Entry in the first row, column 2, this minus 3. This one is saying, is referring to an entry in the second row, column 1, which is this 7. A sub 2, 2 is referring to an entry in the second row, column 2, which is 0. Okay. A matrix with n rows and n columns is called a square matrix. Okay, this is what they are saying. Let me use this one as an example. How many rows are in matrix A?
There are 2.
How many columns in this matrix A?
There are also 2.
2. So this is a 2 by 2 matrix. This is a square matrix. Its size is a 2 by 2 matrix. Now, where should I go? Okay. Let's look at this matrix A. What is the size of this matrix A?
It's 2 by 3.
This one. This. Do you see my cursor?
4 by 3.
Sorry?
4 by 3. Wait, 3 by 4.
3 by 4.
3 by 4 is.
3 by
Yes, I
4.
2 by 4.
Yes. We start with rows, then followed by columns. This one. What about this one? See. What is the size of this matrix?
It's 2 by 3.
2 by 3 matrix. Thank you. Now let me go back to where we were. Okay. We've already seen 2 by 2 matrix, and then square matrix. Okay, what is the size of this matrix? This one, A.
It's 3 by 3.
3 by 3. We agree. What about number B?
It's 4 by 4.
4 by 4. I agree. All right. Now, let me go back. Okay, I was here. Now, these entries that have been highlighted in blue, is it blue or, yeah, I think, no, man is colorblind in nature. Think this is blue. These are the entries on the main diagonal for this matrix. We'll still have to talk more about the entries on the main diagonal of a matrix. Now, please, let's look at operations on matrices. And let's start by looking at this definition. This definition is saying two matrices are defined to be equal if they have the same size and their corresponding entries are equal. Two matrices are equal if they have the same size and the corresponding entries are equal. Equality of matrices. Now, let's consider these two matrices, matrix A and matrix B. If we are saying matrix A equals to matrix B, then we are saying, remember, they are saying they will have to be of the same size and the entries be identical. Then matrix A and matrix B will be said to be equal if, okay, let's say in this case, 2 equals to 2, okay? 1, where there is 1, there is also a 1 in matrix B. Where there is a 3 here, there is also a 3 there. But now, there is an X here, there is a 5 there. There is an X here. If there was an X there, these matrices would be equal. Alternatively, if there was a 5 here, these matrices would be equal. Do we agree?
Yes.
Yeah. Therefore, that is what we are referring to, quality of matrices or matrices being equal. Please, let's come to this definition. This definition is saying if matrix A and matrix B are matrices of the same size, then the sum A plus B is the matrix obtained by adding the entries of B to the corresponding entries of A. And the difference, A minus B, is the matrix obtained by subtracting the entries of matrix B from the corresponding entries of matrix A. Please take note that matrices of different sizes cannot be added or subtracted. We only add matrices of the same size. We subtract matrices of the same size. If they are of different sizes, addition, subtraction for those matrices cannot be performed. Consider the matrices. Matrix A, 3 by 4 matrix. Matrix B, 3 by 4 matrix. Matrix C is a square matrix, 2 by 2 matrix. Therefore, A plus B, matrix A plus matrix B, they can be added because they are of the same size. When we add matrix A and matrix B, this is what we get. We add the corresponding entries. It is these two we are adding. This sign tells us to add. 2 plus minus 4. That's why we've got this minus 2. Okay. And then 1 plus 3. That's where this 4 is coming from. 0 plus 5. That's where the 5 is coming from. 3 plus 1 give us 4. Then minus 1 plus 2. We end up having 1. 0 plus 2 gives us 2. 2 plus 0 gives us 2. 4 plus minus 1 is 3. 4 plus 3, 7. Minus 2 plus 2, 0. 7 plus minus 4 is 3. 0 plus 5 is 5. Do we follow?
Yes, sir.
Okay. Now, the difference. A minus B. We subtract the corresponding entries again. Is 2 minus into minus 4. That's where this 6 is coming from. Then 1 minus 3 gives us minus 2. 0 minus 5 gives us minus 5. 3 minus 1 gives us 2. Minus 1 minus 2 minus 3. 0 minus 2 is minus 2. 2 minus 0. That's where this 2 is coming from. And then 4 minus into minus 1. That's why then we end up having positive 5. Go into the last row. 4 minus 3, 1. Minus 2, minus 2, minus 4. 7 minus 7 minus into minus 4, 11. 0 minus 5 is minus 5. Then A plus C. We can be able to compute or to calculate A plus C because A is a 3 by 4 matrix and C is a 2 by 2 matrix. We can only add or subtract matrices of the same size. So these two matrices, A and C, are of different sizes. Therefore, they cannot be added. We cannot have A plus C. Now let's look at B plus C. B plus C also cannot be calculated because they are because the sizes of matrix B and matrix C are different. A minus C. A minus C also cannot be defined. The matrices are not of the same size. B minus C, matrix B minus matrix C is also undefined because the matrices are not of the same size. You still with me? Now, moving forward, let's look at this definition. This definition, it says, if A is any matrix and C is any scalar, then the product CA is the matrix obtained by multiplying each entry of the matrix A by C. The matrix CA is said to be a scalar multiple of A, meaning when you multiply a matrix by a scalar or a constant, that constant will apply to all the entries in the matrix. Scalar multiples. Okay, we've got matrix A, matrix B, matrix C. Matrix A times 2. All the entries in the matrix are multiplied by 2. So the entries for matrix A are 2, 3, and 4, 1, 3, and 1. So when we multiply this matrix by 2, then we end up having 4, 6, 8, 2, 6, and 2. What are they saying here? When we multiply a matrix by a negative, that negative is taken by all the entries in that particular matrix. Then when we multiply matrix C by 1 over 3, every entry in the matrix is multiplied by 1 over 3. So matrix C has got the entries 9, minus 6, 3, 3, 0, and 12. Now, when we multiply each and every entry in this matrix by 1 over 3, we have 3, negative 2, 1, 1, 0, and 4. Now, let's now talk about this next definition. It says, if A is an M by R matrix, and B is an R by N matrix, then the product AB is the M by N matrix. Okay. What are we saying? We're saying the size of matrix A, better to write it down, A equals to M by R. And then matrix B, the size for matrix B is R by N. So for us to have AB, M by N matrix whose entries are determined as A has got, matrix A has got, the size for matrix A is M by R, and the size for matrix B is R by N, and the product of AB is M by N. Now, that's why I said the size for matrix A is equals to M by R, and the size for matrix B is R by N. And then AB is equals to M by N. All right. Before we proceed, please allow me to say this. In order to multiply two matrices, no problem with addition and subtraction. We dealt with it. But when we come to multiplication, we say the number of columns of the first matrix, the number of columns in the first matrix must be equal to the number of rows in the second matrix. And that's it. Number of columns in the first matrix must be equal to number of columns in the first matrix must be equal to the number of rows in the second matrix. Otherwise, the matrices cannot be multiplied. That is important. Let's consider these matrices. Matrix A, which has got the entries 1, 2, 4. A in the first row. In the second row, 2, 6, 0. And matrix B, which has got the entries. Okay, matrix A, which is a 2 by 3 matrix. Matrix B, which is a 4 by 4 matrix, which has got the following entries. 4, 1, 4, 3 in the first row. 0, minus 1, 3, 1 in the second row. 2, 7, 5, 2 in the third row. Now, first of all, we say A is a 2 by 3 matrix, and B is a 3 by 4 matrix. Then for us to can be able to get AB, the number of columns in matrix A must be equal to the number of rows in matrix B. Is that the case? Yes. Therefore, from there, then we ask ourselves, then what is the final matrix for AB? What is the size of the final matrix AB? So is given by 2 by 4 matrix. Am I making sense?
Yes.
Yes, sir.
Okay, thank you. In this case, please don't get bored. This is what they're saying. These two matrices are used to get the final matrix AB in such a way that the final matrix will have 2 rows and 4 columns. So what does that mean? 2 rows, 4 columns. 2 rows, 4 columns. That means we'll take the first row and run it through the first column. Take the first row, run it through the second column. First row, run it through the third column. First row, run it through the last column, multiplying and adding at the same time. That is how we work it out. Okay, now, this is what we already talked about. We say, for us to can be able to multiply the two matrices, please look at number A and number B. We say M is the in matrix A, M is the number of rows, R is the number of columns. Then in matrix B, R is the number of rows and N is the number of columns. Then for us to can be able to see whether we can be able to calculate AB, we say the number of columns in A must be equal to the number of rows in B. Therefore, in this case, R is equals to R. Therefore, this made this multiplication between A and B can actually take place or can be performed. And then the size of the final matrix will be given by M and N. Okay. Suppose that these matrices A, B, and C are matrices of the following sizes. A is a 3 by 4. B is a 4 by 7. C is a 7 by 3. Then by 3, AB is defined. Now let's see. AB is defined because the number of columns in matrix A is equal to the number of rows in matrix B. That's what I needed to say. Now partition matrices. Multiplication of columns by rows. We've already spoken about multiplication of matrices. Example word. All right. We have got this matrix, which is a 2 rows, 3 columns, is multiplied by this matrix of the size. Row 3, column 1. Okay, I'll tell you. A has got 2 rows by 3 columns, and then row A. No, row A, the size for the first matrix is a 2 by 3. The size for the next matrix is a 3 by 1. Now we say, are the columns in the first matrix equals to the number of rows in the second matrix? Yes. Therefore, the product AB can be computed, and the size of AB is given by 3 by the size of the final matrix is a 2 columns, 2 rows by 1 column. 2 rows, 1 column. Since that column, since the number of columns in the first matrix is equal to the number of rows in the second matrix. Now, matrix product. The first matrix has got the entries minus 1, 3, 2, 1, 2, minus 3, 2, 1, minus 2. Then this 3 by 3 matrix is multiplied by a 3 by 1 matrix. For us to multiply these two matrices, we say the first matrix must have the number of columns that are equal to the number of rows in the next matrix. Okay, let's check. How many rows do we have? How many columns do we have in the first matrix? We've got 3 columns. And then the number of rows in the second matrix, there are 3. Therefore, these matrices indeed can be multiplied. And then After multiplication, we have to determine the size of the final matrix. That size of the final matrix turns out to be a 3 by 1 matrix. All right. Here is another thing that I would like to talk to you about. This equation, AX equals to B. So you will see how it is used in a number of cases. Matrices defining functions. A function using matrices. This shouldn't be difficult. Okay, here is another definition. If we've got this matrix A, if A is any M by N matrix, by saying A is an M by N matrix, it simply means that A is not a square matrix. Do you get that?
Yes.
Then
Yes, sir.
the transpose of A, denoted by A to the T, is defined to be the N by M matrix. The results from interchanging the rows and columns of A. That is, the first column of the transpose of A is the first row of A, and the second column of the transpose of A is the second row of A, and so forth. Okay. Bluntly, please allow me to say this. If you've got the matrix A, and then you are required to find its transpose, this is what this means. This means that the rows in the first matrix will become the columns in the transpose. That is what this means. Do you follow me?
Yes.
Okay.
Yes, sir.
Now, let me not bother you with this one. Okay. Let's look at this definition. They say, if A is a square matrix, then the trace of A is denoted by TR of A, is defined to be the sum of the entries on the main diagonal of a matrix. Trace is given by the sum of them. Trace of a matrix is given by the sum of the entries on the main diagonal of that particular matrix. Okay. Trace of matrix A. The entries in the main diagonal are A11, A22, and A33. This one is a square matrix. Remember, to have a trace, the matrix must be square so that you can have a main diagonal. Main diagonal here are 1, 5, 7, and 0 is the sum of this. That is the trace. Any question up to so far? No question. Do we all follow?
Yes, sir.
Yes.
All right. Please. The next thing that I will, if in the absence of questions, now let me request you to let me close. Let me leave this one. Okay, let's start with this one. In this exercise set 1.3, please suppose that A, B, C, D, and E are matrices of the following sizes. Okay? These are the matrices. Matrix A is, the size for matrix A is 4 by 5. The size for matrix B is a 4 by 5. Matrix C is a 5 by 2 matrix. D is a 4 by 2. E is a 5 by 4 matrix. Now, here is the question. The question is saying, determine which of the following matrix expressions are defined. For those that are defined, give the size of the resulting matrix. Is this making sense?
Yes.
Okay.
Yes, sir.
If it makes sense, then please work out. Let me say number one. Let's say, let me see how many are these. Okay. Please, first of all, work out A to D. A to D. We'll double check the answers for, we'll compare the answers for A to D before we go to those others. A, B, C, D. How many minutes do you need?
3.
Yeah, I'm done.
Thank you. Please, let me start with you on number A. What are we saying?
It's undefined. It's impossible to solve BA, I mean.
Problem solver, what are you saying?
Yes, it is not defined, sir.
Is undefined. BA. Order is important in multiplication. Order in multiplication is very much important. Problem solver, number B.
B is defined, and the size of the final matrix is 4 by 2.
TK, do you agree with problem solver?
Yes.
Thank you, problem solver. TK, back at you. What are we saying about number C?
AE is defined but AE plus B is undefined.
Please come back again.
It's undefined, the whole thing.
Oh, okay. Let's start piecemeal. Piecemeal, I'm saying AE. What about AE? Is it defined?
Yes.
Then
Yes,
AE plus B?
It's not.
Problem solver, do you agree?
Yes, I agree.
Okay, thank you. Now we are back to your problem solver. Number D.
D is not defined, sir.
Not defined. TK,
Yes,
what
it's
are you saying?
undefined.
Undefined.
Yeah.
Oh. TK, what do you say?
Yes, it's undefined.
Undefined. Okay. Now, please, let's proceed. Now, looking at E, F, G, H. How many minutes do you need to work out E, F, G, H? 3 minutes. May I please start with you to share an answer to question E with us?
Oh, okay.
Okay.
Question is defined.
Is it defined? And what is the size?
5 by 5.
Please talk to them.
Problem solver and all other family members, do you agree?
Yes, we agree. I agree.
Okay.
TK, what's your take?
Yes,
TK.
I agree.
Oh, okay.
Yes, sir.
TK, now is your turn. Number F.
Yes, it's defined.
What is the size of the matrix?
5/2.
Please talk to them.
Guys, is it correct?
I agree.
Yes, it's fine.
Thank you. H. Oh, where were we? Where were we? Oh, yes. G. Problem solver.
Yes, this one is not defined, undefined.
Undefined. Please talk to them.
Yes, what did you get, members?
It's the same thing.
It's the same thing. It's undefined.
A.
Oh, okay. TK, I'm back with you. H.
It's defined.
Defined.
Yeah.
What is the size of the matrix?
5/2.
Sorry?
5/2.
5/2. Please talk to them.
Guys, do you agree?
Yes.
Dolly, do you agree? Problem solver, do you agree?
Yes, I agree.
Yes.
I had
Yes.
the same.
Yes.
Okay. Thank you. Now, thank you for having attempted at these questions. Please, now let's go to this next one. Solve the
Yes.
following matrix for A, B, C, and D. Number 2.
Done.
Done. Okay, Dolly, what are you saying? Okay, here we are looking for A, B, C, D. Okay, which one are you? Okay, let me say, Dolly, what is A?
5.
5. I will not comment. I'll go to TK. What is B?
Yeah, I'm lost.
You are lost.
Yeah.
Why are you lost, my sister?
I don't know.
Oh, okay.
I'm stuck.
Okay.
Yeah.
Okay, don't worry. We'll come to you, né? Don't worry, we'll help you out. Problem solver?
Okay.
Yes,
B?
B is -3.
-3. Dolly? C?
4.
4. Problem solver D?
It's 1.
1. Okay. Let me now go back in reverse. Dolly, you said A equals to 5, né?
Yes.
TK, did you get A to be equals to 5?
No.
No. Dolly?
Yes.
Dolly? My sister, would you please help out the sister here on how we arrived at A being equals to 5? TK, please listen
Okay.
attentively and talk to Dolly. We'll come in when where you don't understand.
Okay.
Okay. From the matrix with A minus B, B plus C. Okay, so I equated A minus B to 8, and then B plus C to 1, 3D plus C to 7, and then 2A minus 4D to 6. And then, yeah. And then I had A minus B is equals to 8 as equation 1. And then B plus C is equals to 1 as equation 2. 3D plus C is equals to 7 is equation 3. And then 2A minus 4D is equals to 6 is equation 4. And then solve for those unknowns by Rigba. Okay, I made A the subject of the formula from the first equation. And then I had A is equals to 8 plus B. Are you still with me?
Yes.
Okay, and then from the second equation, which is B plus C is equals to 1, I made C the subject of the formula, and then it became C is equals to 1 minus B. And then I substituted C into equation number 3, and then it became 3D plus 1 plus open the brackets 1 minus B close the brackets is equals to 7. And then I solved for D, which I had D is equals to B plus 6 divided by 3. And then are we still together right there?
You said 3D plus 1, right? Minus B equals to
Yes.
7. And then after that,
And then we had 3D minus B is equals to 6. And we took 1 to the other side.
okay.
So, and then from A, from the equation A is equals to B plus 8, and that one is B is equals to B plus 6 over 3, and then I added them together, and then made them to be equal to 6.
What's wrong, TK? Please talk to us. Don't say Aish alone in your little corner. We are here for each other.
You said 3D minus B equals to 6. And then what's the next step?
And then we will divide both sides by 3.
Then D minus B equals to 2.
Okay, we had 3D minus B is equals to 6, and then we took D to the other side, and it became 3D is equals to B plus 6. And then we divided both sides by 3 so that we can have D as the subject of the formula.
Okay.
And then from that equation of 2, okay, we had A is equals to B plus 8 from equation 1. Do you remember? And then so gamugabona no batho ba baba gamada. Even problem solver more please.
Okay. Problem solver. Hello.
Hello, sir.
Yes.
Hello, sir.
How are you? Would you please?
Yes, I'm good, sir.
Dolly says she's experiencing interruptions where she is. She's requesting that you take over in terms of explaining to TK. TK, please talk to problem solver, then I'll come in if you don't understand.
Okay. Dolly?
TK. Dolly says she's
Who is TK?
Hello.
Yes.
Oh, okay. Oh, TK.
Yes.
So do you have these equations? A minus B is equals to 8.
Yeah.
Okay, so in this equation, okay, let's wait with this one. So now let's go to this one. B plus C is equals to 1.
TK, are you with us?
B plus C,
B plus C equals to 1, yeah.
yes. So make B a subject there.
No, it's 1 minus C. B equals to 1 minus.
Okay. So now in equation A minus B is equals to 8. Where there is B, you see where is this B?
Yeah.
Substitute 1 minus C.
Okay. Yeah, I did.
So what do you get?
I get A minus 1 plus C equals to 8.
Yeah, simplify. When you simplify, what do you get?
To make, oh wait, plus A plus C equals to 7.
No. Try to simplify well.
Sorry. A plus C equals to 9.
Yes, that is correct. A plus C is equal to 9. Yes. Okay, now let's go to, did you get equation 3D plus C is equal to 7?
Yeah.
Okay, make C the subject then. What do you get?
C equals to 7 minus 3D.
Okay, so now let's go to this equation. Did you get equation 3A minus 4D is equal to 6?
3A, yes.
Okay, let's simplify it. What you get when you simplify, just simplify it. Divide by in all the terms.
A minus 2D.
What do you get?
A minus 2D.
Is what?
A minus 2D equals to 3.
Yes, very good. Okay, now make A the subject.
Three plus 2D.
Yes, okay, that is fine. Okay, now you see we have C is equals to 7 minus 3D and A is equals to 3 plus 2D. So let's take these expressions and substitute them in equation A plus C is equals to 9. Do you still remember that one?
Yeah.
The A plus C is equals to 9, yes. So where is this A? Let us substitute the 3 plus 2D. And then where there is C, let's substitute 7 minus 3D.
Okay.
So what do you notice? After substituting?
Now I have the like terms, right?
Yes. Now we are having one equation. We are having an equation in one variable, which is D. So now try to solve for D.
Equals to 1.
Yes, yeah, that is correct. Then now go to equation C is equal to 7 minus 3D. And substitute 1, where is D? What do you get as a value of C?
4.
Yes, that is correct. So then now let's go to the equation whereby A is the subject. A is equal to 3 plus 2D. And substitute 1, where is D?
Yeah, 5.
Yes. Then now let's go to the equation where B is a subject. B is equals to 1. What do you get as a value of B?
Wait, 1 minus -3.
Yes, -3. Yes, that is correct. I think now we have all the values.
Yeah, thanks.
What is your A?
5. B,
B.
-3. -3.
C.
4.
C. C is
C.
4 years. Then
D1.
yes, yeah, that is correct.
Okay, thank you.
Thank you, Dolly.
You're welcome.
Thank you, problem solver. TK. We are here for each other, as I usually say. Then, TK, is it making sense? The way those values for A, B, C, and D were found?
Yeah.
Okay. Are you sure?
Yes.
Okay. Can we proceed?
Yeah.
Okay, thank you. Please, let's look at number. Please don't get bored, yeah? Please. Let's look at number 3. Number 3, consider the matrices. Matrix A, matrix B, matrix C, matrix D, and matrix E. A, 3, 0, minus 1 and 2. A, 1 and 1. Matrix B, 4 minus 1, 0 and 2. Matrix C, the entries are 1, 4, 2, 3, 1, 5. Matrix D has got the following entries: 1, 5, 2, minus 1, 0, 1, 3, 2, 4. Matrix E has the entries 6, 1, 3, minus 1, 1, 2. Lastly, in the third row, 4, 1, and 3. Let me request you to work out, this is number 3. A, B, and C first at once. How many minutes will you need to work out A, B, and C? Okay. Any volunteer for number A, another volunteer for B, and another volunteer for C?
Yes, and the final answer, it's a 3x3 matrix.
Yes.
In the first row, we have 7, 6, 5. Then in the second row, we have -2, 1, and 3. Third row, 7, 3, and 7.
Third row, what do we have?
In the third row,
Yes.
yes, in the third row, we have 7, 3, 7.
Okay, please talk to them.
Yes, members.
I agree.
Did you get the same answer?
Yes, I have the same answers.
Okay, thank you, Dodi. TK, please wake up.
Yes.
If you are sleeping, if you are cooking, please, you will cook after.
Yeah.
Do you agree with this matrix for number 8? TK,
Yes, sir. Yeah.
are you sure?
Yes.
Okay, TK, please share with us an answer for number B.
Okay. D minus E. Yeah, it's possible to solve D minus E because D and E, both of them, they are 3 by 3. So
Okay, I agree.
the final answer is -5, first row,
Hang on, first row, the entries are
-5,
mhm,
4,
mhm,
-5, -5.
mhm.
And then
Okay.
second row, 0, -1, -1. Then third
Okay.
row, -1, 1, 1.
Please talk to them.
Guys, do you agree?
Yes.
Yes, TK, it's fine.
Okay. Thank you, TK. Thank you, members. Volunteer for C, please.
Yeah, go on.
One. Yes, Dolly. Listening.
It's
Thank you, my sister.
oh,
Hmm.
okay. It's in the first row is 15, 0, and then the second row is -5, 10, and then third row is 5, 5.
For the last time, my
Do you
sister.
guys agree? Pardon? For the
Please
last time?
repeat. Yes, please repeat.
Okay. First row, we have 15 and 0, and then second row is -5 and 2, and then third row is 5 and 5.
Only first, I captured the first row. There is something that I
Second row,
didn't. Yes, second row. Mhm.
-5, and
Mhm.
then 10,
Oh, okay. Okay.
and then third row is 5 and 5.
I agree. Is there anyone who disagrees? No. Okay. Now, 7. Okay. Maybe we can. Okay, that was up to C. Let's say D up to. Let's work out D up to F, and then we'll make a decision about the remaining ones. D, E, F.
Sorry, sir. In F, is it 4B or is 4E?
4E. Okay, let me do this.
Or is 4E?
Is it clear now? 4E minus 2D.
Yes, okay, yeah, it's clear now.
Okay.
I think we're done, sir.
Okay. Let me request for any volunteer for D, E, and F. Any volunteer for D?
Yes, I can take.
Okay.
We can take D.
Okay, my brother. Please go ahead.
Yes, this one is possible. We get a 2 by 3 matrix.
Hang on.
In the first row,
D minus E, ne? Okay. Okay, please start. What are you saying?
yes, it is
Is
possible
D
to compute
is
this one.
possible.
Yes, and we obtain a 3 by a 2 actually, a 2 by 3 matrix. And in the first row, The entries are -7 and -28 and -14. Then in the second row, we have -21, -7, and -35.
I fully agree with that.
Yes.
Okay, do you agree? Dolly, do you agree?
Yes, I agree.
Okay. Then any volunteer for number E?
Yeah, go on.
On. Please go ahead, my sister.
It's not possible because the matrix, the first matrix is 2 by 2, and then the second one is 2 by 3. So we cannot have the difference.
I agree with you, Don. So 2B minus C is undefined, okay? Based on the fact that B is a 2 by 2 matrix, and which other one?
C is 2 by 3.
Or C is a 2 by 3 matrix. So that operation cannot be performed. So that is undefined. F, let's see what F is saying. For E minus 2D. Now let's go to the matrices. For E minus 2D. Any volunteer? TK, what are you?
Yeah.
Okay. So for E minus 2D, 4 multiplied by E is 24, 4, 12, then second row, -4, 4, 8, third row, 16, 4, 12, then 2 multiplied by D is 2, 10, 4, -2, 0, 2, 6, 4, 8. So E and D, they're both 3 by 3. So it's possible to calculate, to subtract E minus 4E minus 2D. So the final answer.
Yes.
The final answer is 22, -6, 8, -2, 4, 6, 10, 0, 4.
Please repeat, my sister. The final matrix.
First row, 22, -6, 8. Then second row, -2, 4, 6. Third row, 10, 0, 4.
Thank you, my sister. Is there anyone who disagrees with TK?
No, we agree.
We agree. Okay. So, please, let me request that we stopped at F. Let me see here. At F. Can I request that we this is 3, number 3. Then we take it from G up to L.
Yeah.
Do we agree, members?
Yes.
Can we agree that we'll start by checking? We'll start by checking the answers for number 3, G to L when we meet.
Thank you guys for joining. Thank you for attending. Thank you for participating.